So someone wanted to know about incongruous visual field defects and how to differentiate that from the optic tract lesion, especially using band atrophy. And so if you remember the visual pathway, it starts in the retina, the nasal fiber crosses in the optic chiasm, and the temporal fiber remains uncrossed. And so for when you're in the tract, you have both an uncrossed temporal fiber and a crossed nasal fiber from the other eye. And so if this is the right and this is the left, a right optic tract lesion here is going to produce a left homonymous hemianopsia. And the reason it's going to be incongruous when you have anterior visual pathway disease versus a cortex lesion, like in your occipital cortex, is the fibers are very spread apart topographically. When they come out of the chiasm and they go to the radiations, the fibers are radiating out, and that means they're spread out. And so that spread is what produces incongruity. When you're getting to the occipital cortex, all the fibers that were radiating out have to focus on one spot. And so when you get a lesion in the occipital cortex, it produces a field defect that is a homonymous hemianopsia that is very congruous. It looks exactly the same in both eyes because the topographical representation of those fibers is very precisely aligned with the other eye. If you're in the anterior portion of the retrochiasmal pathway, the fibers are spread out, and therefore you're going to get an incongruous visual field defect the more anterior you are. So the more anterior in the retrochiasmal pathway, the more incongruous, and the more posterior you are in the occipital cortex, the more congruous, meaning it looks exactly the same. So congruity helps us define whether we're in the posterior or the anterior portion of the retrochiasmal pathway. If you have a lesion of the geniculate body, that is where the cell body of this axon lives. And so any lesion that produces a homonymous hemianopsia is going to produce optic atrophy that's going to be visible in the eye because the cell body has been disrupted, and therefore we'll have retrograde degeneration back to the eye. And in a homonymous hemianopsia, in this example, a left homonymous hemianopsia, the right eye has a nasal hemianopic field defect and the left eye has a temporal hemianopic field defect. And so in the eye, what we see is we're going to have the eye that has the nasal loss of field is the temporal fiber, and so that atrophy will look like an hourglass because this is the temporal fiber, superior temporal and inferior temporal fiber. And the eye with the temporal field defect is going to have nasal fiber loss, which is like a band or a bow tie across the optic nerve. And so that bow tie atrophy tells us that we're going to have a tract lesion if we have a homonymous hemianopsia. And in the bow tie atrophy eye, that is from the crossing nasal fiber, which produces the temporal field defect, and that means it'll be in the contralateral eye. Right optic tract, left homonymous hemianopsia, left eye has the band atrophy.